So if you look at example 10, it's already written in expanded form for you. So you don't have to do any rewriting, but just an FYI, you potentially could have. I wrote it off here to the right. Log base 3 of 5 minus x to the 4th squared. It looks kind of funny having a subscript and a superscript, but it is legal. Okay, so just like we do with sine and cosine, if you see a log, like over here, the natural log squared of x, that's the entire thing squared. It's not as customary to do it when you have a base that's not E or 10, because it kind of makes it look a little bit awkward, but it's perfectly legal. So that would be your first step, is to write it like I gave it to you. But now it's just peeling the layers off, right? Blob squared becomes 2 blob to the 1st, and then we just rewrite the blob. So that's just the power rule. And then times the next layer is the log layer, right? We have log base 3. So what's the derivative of log of blob? It's 1 over the blob. And now because it's not base E, I have to divide by the natural log of the base. If I write it like that, is that good enough? Look how I wrote it. 1 over the blob times the natural log of 3 in the bottom. Yeah, parentheses. If you write it like that, these are the only 2 that's getting multiplied. So yeah, you got to have that in parentheses. And then finally, times the chain rule, the derivative of the blob is negative 4x cubed. Boom. And there's your answer. Okay. So if it's exponential, multiplied by the natural log of the base when you differentiate. If it's log, divide by the natural log of the base. Okay, that's it. What's that? Negative 8x cubed log over. Yep, that's perfect. Yep.